Welcome back, everybody. We are going to finish up section 3.5 and talk about solving systems by elimination. So a reminder about elimination, remember we're trying to make it so that one part of our equation adds to zero or eliminates. Make sure all your variables are lined up. You can multiply, if you need to, one or both equations to create a set of opposites that will add to zero. Once we've done that, we add the equations together. One variable should eliminate out. Solve for the remaining variable. Substitute in the solutions to solve for whichever other part you need. All right. So I'm checking this very first set. I've got x squared lined up, x to the first lined up, my y's lined up, my equal signs are lined up, and then my constants are lined up. So if I add these two equations together right now without doing anything extra, does something add to zero? And the answer to that is yes. My y's add to zero. So I get 3x squared minus 3x is equal to -2. Well, now I know in order to be able to factor or use quadratic equation, I have to have an equation equal to 0. So I'm going to go ahead and add my 2 over and put this in standard form. So first I check, is there a greatest common factor I can reduce by? No. 3 times 2 is 6. Are there factors of positive 6 that add to -3? And my choices are 6 times 1 and 3 times 2. So that's not going to work either. All right, not factorable. That's okay. Still solvable. I'm going to go ahead and use my quadratic formula. I've labeled my A, B, and C. So I have x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Well, I know these change to +3 plus or minus. Let's look underneath our radical. -3 squared is +9 minus 4 times 3 is 12. 12 times 2 is 24. So under the radical, I have 9 minus 24, which is -15 over 6. Well, I have a radical with a negative underneath it. What always comes out? What letter? It's the letter I, because we can break this into the square root of -1 times the square root of 15. So this is 3 plus or minus I square root 15 over 6. Well, I is imaginary, and we don't know how to graph imaginary values. So that means this graph has no solution. Example 2. Well, again, I want to make sure that everything is lined up nice and neat. So I think I'm going to rewrite this. I have 2x squared, 4x, y, x doesn't want to write. And then we have x squared plus y is equal to 2. So everything lines up, and if I add together right now, again, my y's are going to add to 0. So 2x squared plus 1x squared is 3x squared. And we have this 4x is equal to -2 plus 2 is 0. All right, so my equation already equals 0. Let's see, our first question is always, do we have a common factor? that we can pull out? And the answer is yes, they both have an x. That leaves us with 3x plus 4. Okay, well now we can set our variables equal to 0. Every x gets set equal to 0. This one on the left is done. It's already solved. The one on the right will subtract 4. 3x is equal to negative 4. And then divide by 3. And we get x is equal to negative 4 thirds. Awesome. Well, now we need to figure out what equation we want to put this into to get y alone. And I think I'm going to go ahead and use that bottom equation. I'll start with the 0. So we have 0 squared plus y is equal to 2. Well, 0 squared is 0. And this 0 really isn't anything there, so we have y is equal to 2. So our first solution is 0, 2. All right, now we plug in our negative 4 thirds. So we have negative 4 thirds squared plus y is equal to 2. Well, it's not pretty, but that's okay. We're not afraid of fractions. Negative 4 squared is 16. 3 squared is 9. We're going to subtract 16 ninths from 2. Oops. So we had 0, 2, and right now we're at y is equal to 2 minus 16 ninths. Well, I can make anything into common denominators by starting with putting a 1 underneath it and then multiplying. So we have 18 ninths minus 16 ninths, which is 2 ninths. So our y is 2 ninths. So we have negative 4 thirds, positive 2 ninths. And these are the two solutions to our system. Thanks, everybody. Have a great night.